This is a CCEA M7 paper 1. This is a non-calculator bit, obviously, and this one's from June 2023. So let's take a wee look then at question 1. There are 30 pupils in a class. 3/5 are girls, 2/9 of the girls are absent, 25% of the boys are absent. Complete the table below to show this information. So 3/5, so straightforward enough here. So we know 1/5, so a fifth of this then would be 6. So 3/5 would be 3 6s, so that then would be 18. Obviously, with 30 in the class, there we're going to have a 12 here. 2/9 of the girls are absent. It sounds like a complicated fraction, but it's okay because it's 18. So 1/9 of this would be 2. So 2/9 then is going to be 4. And it means the present ones then are going to be 14. 25% of the boys were absent. So 25 is a quarter. So dividing this by 4, then we would get 3. And that then gives us 9. Pencil's just broken here. What fraction of the pupils are present? So present here we have 14 plus 9, which is 23, and of course there's a total of 30 pupils, so the answer then would be 23 over 30. Question 2. The pulse rate of an athlete is taken before and after training. His pulse rate is 54 beats per minute. After training is increased by 1/6 of this value. Show that each beat now lasts less than a second. So 54 beats per minute, and we need to add 1/6 to that. So we need 1/6 of 54. So that's obviously 54 divided by 6, and that gives us 9. So whenever we add that, our 54 plus 9 gives us 63. So it's 63 obviously then beats per minute, and if we have 60 seconds in a minute, then obviously because 63 is bigger than 60, then it's more than 1 beat a minute, and that's a reason for that. 2 fair spinners are each spun once. One of them is 10, 20, 30, 40 on it. One of them is 1, 2, 3. The scores on each spinner are multiplied together. Complete the table of outcomes. So we're just going to multiply across here then. So 1 times 10, 20, 30, 40. 2, 20, 40, 60, and then 80. And then 3 times 10, 3 times 20, 3 times 30, and 3 times 40. What is the probability that the outcome is 60? So we have 2 options there, and that's out of the 12. So it's going to be 2/12. That cancels down then to a 1/6. What is the probability that the outcome is less than 40? So less than 40, we have 1, 2, 3, 4, 5. So that's 5 out of 12, and that doesn't cancel out any further. Probability that child is left-handed is Q. What's the probability that child is not left-handed? So this is a bit of a strange one. Normally they give you an actual number here and we take it away from 1, but that's exactly what we do with the Q. We just go 1, take away Q. Given that 23 times 146 is 3358, write down the answer to this. So with 1 move along the decimal place there, and with 2 moves in there, so we need to move 3 from here, so we need to move then to there. So it's going to be 0.358. Showing clearly how you do it, estimate the answer to this. So our general rule then is to go to one significant figure. So we're going to go 200. 29 into one significant figure is 30. And then that's divided by 0.5. 200 times 30, we do the 2 times the 3 gives us 6 over 0.5. And just be careful with this here. Dividing by 0.5 isn't the same as halving it. It's exactly the opposite. How many 0.5s in this? So it's twice as many. So the answer is going to then be 12,000. In April, 30 males and 20 females took their driving test. 50% of the males passed and 40% of the females passed. What percentage of people who took the test failed? So we know that 50 people took the test. And let me see, so we had 15 males pass and 40% of the females passed. So 10% of this would be 2. And so that then is going to be 2. So 10% is 2, so 40% is going to be 8. My 15 plus 8, I think, then gives 23. So 50 people took the test, 23 passed. So take away 23 is going to be 27. What percentage? So it's 27 out of 50. I guess we can times both of those by 2. That would be the way I would do it, and just do it over 100. So times that by 2, times that by 2. So 54 over 100, which then is the same then as 54%. On to question 7. So there's A and there's B. It says describe fully the single transformation that maps A onto shape B. So we can see we're going from here to here. It looks to me like it's a translation. Nothing's been turned around. There's nothing reflected. If it was reflected, it would be the other way around. And so this is just a straight translation. So we need to write the word translation first of all. You can write this in a couple of different ways, but be careful here because we need to go from an equivalent point to another one. So it's from A on to shape B first of all, and so I'm going to go from this point here to this point here. Can we see that that's the equivalent one? So it's going to be 1, 2, 3. So it's 3 across, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So we could write 3 and 9 as our vector, or if we want 3 across and 9 up. A sketch of a parallelogram PQRS as shown. It is not drawn to scale. Use a ruler and protractor to draw an accurate diagram of the parallelogram in the box below. Now I'm going to fortunately have to do a cheat here because I don't have a compass on me. I'm embarrassed to say. So ruler and protractor, they were okay. I thought we needed that. So we're going to do our 9 centimeters going along first. And obviously do it over to this side because it's going to be 110 degrees, so as accurately as I can. There's going to be my 9 centimeters there, and that's S, and that's R. I then need to go 110 degrees. So again, as accurately as I can, I'm measuring this round. So it's 0 there, and we're going round there. There's 100, there's 110 there. We'll do a nice light line here, and then measure the 7 centimeters after that. So there's my line, and then if I line up the 7 there, do you see what I'm doing? That's going to take me then to that point there. The problem is whenever we try and draw this along here, is that definitely 9? That's 9, yeah, and that's 7. We are good. And so problem whenever we draw this, it's very hard to get it then kind of parallel to this, but we should know our angle. If that there is 110, then that angle there is going to have to be 70. So I'm going to measure it. Remember, you can turn this round as well to make your angles worthwhile in terms of measuring, make it nice and accurate. So again, I'm right at the end here, I'm measuring around, so there's 70 there, so that should take me then in the right direction. Doesn't particularly look like it, but I think that's right. So then it should be another 9. Again, let's remeasure that to make sure again we're as accurate as possible. And then if I join those two up, it should give me the right bit, and that should be roughly 7, which isn't bad. We're close enough, I think, then for that. So that's at S and R, and that's Q, and that's P. Not my best ever parallelogram, but I think we're good. Tony owns a pizza takeaway. Every time he sells 100 pizza, he records the number that were pepperoni. The table shows some of his data. So number of pepperoni pizzas, 17, 23, 23 and 25. That's out of kind of each of those 100s. And then we have to complete the table. So the probability here was 17 out of 100. So that's obviously 0.17. So we need our probability here. So we need to add these four numbers here. So it's then going to be 17 plus 23 plus 23 plus 25. So 17 and 23. I mean, to be honest, we should just set it up like this with our non-calculator. 7 and 3 is 10, and that's 18. 2 and 2 and 2 and 1. I think then that gives us 88. So that's going to be then 88 out of 400, and that cancels down then to 22 out of 100. So that means that one's going to be 0.22. If it's 0.23 and then it's out of 500, if I do 23 times by 5, I'll get then 115, and so it'll be 115 in this one here. That's totally wrong. It's 115 is going to be my total, so I need to do 115 taken away from my 88. So I take away my 88 then from that, and I get 27. 27. Tony uses his data to predict next year's pizza sales. He thinks he will sell 2,300 pepperoni pizzas next year. How many pizzas is he expecting to sell in total? Well, we know our probability then is 0.23. We use this one because this is the one with the most information. This is taken out of the 500 pizzas rather than the 100. So we would be doing then 2,300 divided by 0.23, and that then is going to be 10,000. Question 9, by drawing a suitable line on the grid, solve the simultaneous equations. So this one here has been drawn for us, and we want to draw this one. Couple of different options here. You can do what you want. You could do some x values and some y values. For example, minus 2, 0, 2, 4, 6. I'm just grabbing that from these numbers that they've given us here, substitute it into that. What I'm going to do is use my y equals mx plus c. So that 3 tells me that it crosses the y-axis at 3, and my gradient of 3 then means every time I go across 1, I go up 3. So it's across 1, up 3, across 1, up 3, and so on. And then I can extend that down. Hopefully you see where I'm going from here, and so we can then draw our line on. So that's our line there, and the name of that line is y equals 3x plus 3. We're looking for the coordinates then of where they cross, so it's this bit here. The x coordinate's minus 2, and the y coordinate then is minus 3. So it's going to be minus 2, minus 3. Question 10. The first four terms of a sequence are 1, 4, 7, 10. What's the nth term? So what I do is I number them 1, 2, 3, and 4. Then I find the gap, and the gap in this case is 3. That means my sequence begins with 3n. I then substitute the number 1 into this. Sorry, number 1 into this. 3 times 1 gives me 3, but I want 1. So it's then going to be 3n, take away 2. Hence, find the nth term for the sequence below. Number them 1, 2, 3, and 4. The secret generally with these fractiony ones is to take the numerator, that's the number on the top, and the denominator separately. So look, 1, 4, 7, 10. That's why they've used the word hence there, because you can use what you've worked out. So the bottom bit is just my 1, 4, 7, 10. So the bottom bit of the fraction is going to be 3n minus 2. And they're looking for you to recognize these numbers here. 1, 4, 9, 16. Well, those are just the square numbers. 1 squared, 2 squared, 3 squared, 4 squared. So I write my n squared here. Question 11 then. In standard form, 2 times 10 to the x times 3 times 10 to the y equals 6 times 10 to the 11. So the 2 times 3 gives us 6, so that's good. And that means then if we just kind of add these powers here, we're going to get that. So that actually means x plus y must be 11. In this one here, 3 divided by 2 gives me 1.5, so that's good. And then the y and the x, and of course if you're dividing you subtract the 2 powers, so it's going to be y minus x equals 3. This is simultaneous equations. Now I don't like the way I've kind of these written, so I'm actually going to just reread them here. I'm going to go y plus x equals 11, and then y minus x equals 3, and if I add these, then the x's are going to disappear. Y plus y is 2y, and that gives me 14. So that means y is 7. And obviously if x plus y is 11, I substitute my y equals 7 into this. X plus 7 equals 11. See what I've done? I've taken this one here and changed my y for a 7, and then that gives me x is 4. The semicircle and the triangle have the same perimeter. Find the exact value of r given your answer in terms of pi. So the semicircle perimeter, so remember the perimeter or the circumference of a circle is 2 pi r. So the semicircle perimeter is going to be half of that, that's half of the circumference, and then plus an r plus an r. So instead of 2 pi r, it's going to be pi r plus 2r. The height of this one, we're going to have to use Pythagoras here. So let's do it up here. A squared plus b squared equals c squared. If I go then a and b and c, remember c has to be the long one, so that's going to be 4 plus b squared equals 3 squared, which is 9 obviously, so that means b squared is going to be 5 with no calculator, remember. So b then we just write then as the square root of 5. So what does that mean? That means pi r plus 2r equals this plus this plus this, because that's my perimeter. So 2 plus 5, so it's going to be 5 plus root 5. Find the exact value for r given your answer in terms of pi. So we don't need to do any calculations here, we just need to rearrange. This is messy too because there's an r here and an r here. The way we get the r on its own is to factorize it out. So it's going to be pi plus 2 equals 5 plus root 5, and then to divide that, so divide by the bracket, 5 plus root 5 pi plus 2. So we're going to go 5 plus root 5 all over pi plus 2, and that's the answer they want. Finally then, question 13, a dice is rolled once and a coin is flipped once. Here are the 4 possible events. So the roll of the dice is even, the roll of the dice is odd, the flipped coin lands heads, the flipped coin lands tails. Write down 2 of these events that are independent, so they're kind of nothing to do with each other. For example, the dice being even and the coin being heads would be one. There's lots of different options there, but I'm going to go in for A and C. Write down 2 events that are mutually exclusive. It's mutually exclusive means they can't happen together. So we could get an even dice and a heads, so that could happen together. So it needs to not be able to happen together. So even and odd, you can't roll the dice and it be even and odd at the same time. So event A and B would work then for us here. 2 events P and Q are mutually exclusive. What's the probability that either event P or event Q occurs? Well, if it's an OR, then we generally add the probabilities, and if they're mutually exclusive, then we can just add them together, and that should give us the answer. So circular answer. So it's going to be the probability of P plus the probability of Q.